Okay, welcome everybody. This is the test 2 review, and I think I'm recording. Yes, I am. So I went through the test, and then I went through the review, and I'm going to find some problems very similar that are on the test. So uh-oh. Our our test is over the following section. So this is what our test is over: 2.6, 2.7, 2.8, 3.1, 3.4, and 3.5. So these are the sections that the test is over. So I just want to make sure everybody understands. I would focus on these sections here on the test. And I'm trying to go back and forth to computers. I'm looking at the test and I'm looking at the review.
Are you going to record this session?
It is recorded right now.
Okay, I didn't see it. Thank you.
Recording to the cloud. Yes, it is recording. All right, so let's look at the first one. In 2.6, I'm looking at problem 10. So if you go to your workbook, 2.6, number 10, you have to be able to graph a piecewise function. And in reality, all you have to do is pick the correct graph. It's multiple choice. So it's kind of important to be able to graph this. So there's two functions we're going to graph. The top one, which is y equals 6x plus 2, and the bottom one, y equals 2x squared minus 2. So if you look at this first one, that's a straight line. When we just have x without a power or anything, it's a straight line. And you can do test points or however you want to do it. You can say x is 0, so y is 2. X is 1, so y is 8. So if you look at this, 0, 2 is right here, and 1, 8 is right here. So if you connect this line, it's supposed to be a straight line. If you connect this line, but look at the restrictions. X has to be less than 0. So this top part isn't part of the graph. You see the x values have, here's x0. You can only graph it when x is less than 0 that way. And if you look at it, x is less than 0, there's no equal sign on that. So this is an open circle. It shouldn't be filled in. Sorry. It should be an open circle and then going down that way. On this one, this is x is greater than or equal to. Remember, x squares are parabolas. A minus 2 means it goes up to. From here, it goes up to, so there's a point here, it equals, and then it goes up. So you just have to be able to graph both of them and look at the restrictions. See the restrictions here for x is x has to be greater than 0. So the parabola is on this side of the graph, greater than 0. So that's just what you have to look at. Remember, when there's just an equal sign, there's just a hole at that. If there is an equal sign, you have to fill it in and then draw it. All right, so that's the first one. You just have to pick the correct graph on a piecewise function. Then I'm going to go all the way to 3.1 right now. That looks like the only type of problem on that first one. Wait, oh, 2.7. 2.7, number 5. And there's quite a few problems in this section here in 2.7. And I think that might, hopefully that's the easiest one. Number 5, can anybody tell me what this graph looks like? Can you tell me what this -8 and what this +7 means? Can anybody tell me what the +7 means?
Moves to the right 7.
Oh, be careful. On the outside, it moves up or down. So this one moves up 7 spots. On the inside, it moves right or left. If it's a negative, it moves right. If it's a positive, it moves left. So it's a negative, it moves right. So, I mean, if I was looking, if there were 3 graphs on a piece of paper, if there were 3 graphs, let's say this one, there are 4 separate graphs, not 3, 4 separate graphs. This graph moves up 7 and to the right 8. Up 7 and to the right 8. So this has to be the correct graph. Up 7 to the right 8. Do you see this is to the left? So that can't be. This is down and to the left. This is down. So it has to move up 7 to the right. You have to know what the insides and outsides mean. The outside of a function is going up or down. The inside is going left or right. And the inside is always opposite what you think. You think a negative goes to the left, but a negative goes to the right. So that's number 5. I'm going to number 7 now. And stop me if you have any questions. And you have to be able to write the equation for this. And once again, it's multiple choice. So there are going to be some equations. It's going to say F equals x squared plus 3. F equals x plus 3 plus 2. F equals x minus 3 plus 2. F equals x plus 3 minus 3. A, B, C, D. You have to pick the correct answer. So I'll give you a second to think about it. Nobody yell the answer out. And so now somebody tell me the answer.
A.
C.
So the answer looks like it's C. Look what, see, here's a normal parabola. It went up 1, 2 spots. Do you see? Up 2. So there should be a +2 on the outside. It can't be that one and it can't be that one. Then it moved to the right, 1, 2, 3. Do you see the vertex move to the right 3 spots? Remember, to the right is opposite. Right is positive side, so the right is actually a -3. So the answer is C. On the inside, a negative means you're moving to the right. On the outside, a positive means you're going up. So the correct answer is C. All right, that's number 7. Number 8. We have quite a few problems in this section here. So I'm going to draw a couple of graphs. Let's see if we can, I'm going to draw like that. Let's see if we can pick the correct answer. A, B, C, and oh, wait, D, E, F. I'm going to make it really hard for you guys. Okay. What? Which one looks like A, B, C, D, E, or F? I mean, it's going all over. So without looking at the pictures, don't look at the pictures. Let's show what's going to happen. We're going to go up 2 spots, a +2 on the outside, right? Our normal function is just the square root of x. So a +2, and they're all up. It looks like they're all above the, you know, the x-axis. They're all at 2. Then there's a -1. A -1 moves to the right 1 spot. So we go up. So this is the normal square root function. But we got to go up 2, and then to the right. A negative on the inside goes to the right. So this one went to the left. This one went to the left. This one went to the right, 1 spot. This one went to the right, so we're okay there. This one went to the left, or to the right. That's good. This one went to the left. That's not good. And then the only thing else we have, so we have 3 possible answers. We have a negative on the inside of the function. So if you remember, here's the original function. If we had a negative on the outside, then the graph would be like this. It flips on the horizontal axis. But a negative on the inside flips it on the vertical axis, on the y-axis. A negative on the inside of the function. This is the negative on the outside. So the negative is on the inside of the function, so it should look like this. And the only one that looks like that is none of them. I think I meant to do this one, but I didn't put it far enough. So in reality, the graph, let me erase one of these bad ones. So this graph goes up to, here's a parabola. It goes up, here's the, square root graph. It goes up to the right 1, and then it goes opposite, it goes the opposite side on the y-axis. If it was on the negative on the inside, it flips down horizontal. But this one goes on the inside, so it flips the other way along the y-axis. So this is the correct answer for this problem. And don't get caught up on, oh, it has to look like this. It's going to be, you know, there'll probably be a square root graph. There'll probably be a square root graph somewhere, but the shifts will be a little bit different. Okay, something's wrong. Oh. What happened? Why isn't it plugged in? My cord unplugged for some reason. Where is it? The computer's about to go out. There we go. Must have disconnected the plug. All right, so the next problem. That was 8. We are going to number 9 and 10 on this section. So we have, like I said, we have quite a few in this section. Number 9, you have to be able to draw the correct graph again. Let me draw a couple of graphs. We can have one graph here. By the way, absolute values are V shapes. We can have one graph here, one graph here, and one graph here. A, B, C, D. And which graph is it? Anybody? Is this microphone on? A -7 means the graph goes down. This is what the V shape normally looks like. And then a 2 means, remember what the 2 means? It gets skinnier or it stretches up. So let's not say skinny because the book says stretches. So it actually stretches up and it goes down 7. So it goes down 7. So here's the 7 spot. So this is the correct answer here. It's just a graph that goes down 7. We have to know what all those mean. And next is number 10. Now, I will admit, this might be the hardest question on the test, one that looks similar to this. But let me do away with this function. Let's do, this is our, it's going to say, this is our function, okay? Let's call this our function. How would this function look if we, see, this is our function. We're just calling it a function. We don't know what the equation is. We're just calling it a function. How would this function look if we did these transformations? A +5 means the graph moves up, and a -2, let's put a +2 on the inside. A +2 means the graph moves left 2 spots. So this whole W moves up 5 spots and then left 2 spots. Do you see? If we look at this point, it moves up 1, 2, 3, 4, 5, and then up to the left 2. And then you can draw your W. So if you look, just, you know, each point, this point goes up 5 and then over 2. This point went up 5, that point would be right here, up 5 and then over 2. This point, it was here, up 5 over 2. If you, I mean, it's best to just pick one center point and go up 5 over 2, up 5 over 2. So this whole graph, so we're not looking at just we're looking at the entire graph when we say function. It goes up 5 and over 2. That's all they wanted to see. So we're doing number 10, but it's a little different. So I changed number 10 because to make it look like what was on the test. We didn't have anything like this. We did this one in class, but I mean, that particular one is not similar to the test. I'm going to 2.8, number 3 and 4 now. 2.8, number 3 and 4. So this is the two functions dividing. F is on top and G is on the bottom. So we're going to put F on top. Here's F. 2x minus 2 on top, and G on the bottom, 2x squared plus 14x plus 5. So there's a couple of ways of doing it. You can plug the negative, by the way, you're plugging negative 3 into the x. That's what it says. So I'm just going to go ahead and do this. Plug negative 3. Let me erase it and try it differently. So it's 2 times x minus 2, 2x squared plus 14x plus 5, and we're putting negative 3 everywhere we see x. So on the top, 2 times negative 3 minus 2, you get negative 8. On the bottom, Lord help me, I get 9 and 2, that's 18, minus 42 plus 5, I get a negative 19. So negative 8 divided by negative 19 is 8 over 19. Don't change it to a decimal. That's what the answer would look like. So remember, if it says you're going to divide these two functions, f goes on top, g goes on the bottom, and you're plugging negative 3 everywhere you see x. Four is the same way, except here we're going to take f. F is x minus 1, and we're going to multiply it times g. And g is 5x squared plus 19x minus 3. Everywhere you see an x, we're going to plug a negative 4 into it. So I'm going to rewrite this. X minus, oh, that's the wrong one. X minus 1 times 5 times x squared plus 19x minus 3. And I'm going to plug negative 4 in every x spot. So first, negative 4 times negative 4 minus 1, it's not multiplying, it's negative 4 minus 1 is a negative 5. Over here, I'm going to have to put all that in my calculator. Did anybody else get one? Do you guys remember when we did this? I ended up with a 1. So negative 5 times 1, I ended up with 1 when I put all this into my calculator. And negative 5 times 1 is negative 5. So you're just taking those two functions, plugging negative 4 in, and that's what I got. Any questions? Questions? I'm going to number 11. And remember, this is the symbol for composite. And composite means first we have to find this answer, f of negative 9. So everywhere there's a function f, and we get negative 8, minus 9. Everywhere we see the x value, we're plugging negative 9 into it. Do you see? We do the far right first. The f, we plug negative 9 into f. Here's f. And we plug negative 9 into it. This is 72 minus 9. When you do that, you get 63. So I got 63 when I got this answer. You take this answer, 63, and plug it into the G. Whatever you get for F, negative 9, you plug that answer into G. So this 63, I'm going to plug into the X values for the G. Negative 9, X squared minus 8X plus 5. And I'm plugging 63 into those spots. And I'm going to put this in my calculator. Negative 9 parentheses 63 squared raised to the second power. Bring it down, negative 8, or not negative 8, subtract 8 parentheses 63 close parentheses plus 5. And I get negative 36 to 20. If we get something different from what we got in class, let me know if anybody has their workbook out. But that's what we get. Remember composites, you have to find the right function, plug 9 into the f function, find its answer. When we found the answer, we got 63. Now you're plugging 63 into the G function. You're taking that 63 and plugging it into all the x's for the G function. And that's what I got. Now there's also one that I couldn't find on here, but it's really similar to this number 11. It's the same thing, but we're not plugging a number in. But we're not plugging the number in. And let me change the problem. So this is 11b. I'm going to change G. I'm going to change G to negative 9x plus 7. So this is a second G. This is a second number 11. 11b. So if we don't have a number in here, that's okay. So first we have f of x. This is our answer. F of x is just negative 8x minus 9. We're not plugging anything into the x. We're leaving x there. So it's negative x minus 9. When we do f of x, it's just negative 8x minus 9. That's our answer because there's no number we're plugging in. It just says x. Then we're going to take this whole thing and plug it everywhere we see the x's in G. So G is negative 9x plus 7. So since we don't have a number, we have this. We have to plug that into the function, negative 8x minus 9. And then we have to simplify. So you have to distribute. Negative 9 times negative 8 is a positive 72x. Negative 9 times a negative 9 is a positive 81. These two can be added together. And there's my final answer. This is G of f, function f. When we plug x into the function, when we're not plugging a number in, we're just leaving the x alone. So there'll be one similar to this, the 11b, where you're not going to plug a number in. Let's go to number 13. Yes, there is one of these. Remember, first we have to find composite, we have to find the far right first, f of 9. F of 9, the function f is this one. This is the function g. So when we find f of 9, we're going to stick with our function f. And this is the x value. The x value is 9. Do you see how that 9 corresponds to this? The answer is the y. So the answer to f of 9 equals 10. That is the answer. 10. We have to take this answer, 10, and put it into the x value for g. Well, here's g, and do you see how here's the 10? You're plugging 10 into g. Here's the x value for g. And the answer to this, the y value is the answer. The answer to that is 19. And that's the final answer. The function g of f when x equals 9 equals 19. First we find this, the answer to that, and the answer to that was 10. The y value is the answer. Now I find g of 10. G of 10, the y answer is 19, and that is my final answer. All righty. I am going to 3.1. We're going to do 5, 6, 7, and 8. Okay, identify the vertex. And then it says write the equation in this form. Well, can you, I'm looking at the test real quick also on this one. Graph. Not only find the vertex, yeah, it says, this one just says identify the vertex. Or graph this function, that's fine. Okay, so we're going to identify the vertex first. We're going to identify the vertex. If you're going to graph it, you have to find the vertex. By the way, it's an x squared graph, so I know it's a parabola somewhere on my graph, right? So the vertex, to find the x value of the vertex, don't forget it's negative b over 2 times a. A, in this case, is the number in front of x squared, which is 1. B is the number in front of the x, negative 20, and then that's c, but that's not part of our formula. So negative b divided by 2 times a. B is negative 20, and a is 1. Negative, negative here is a positive. 2 times 1 is 2. So our vertex is at 10. Our x value of our vertex is 10. How do I find the y value? Anybody remember how to find the y value for this? Anybody alive?
Obtaining the equation.
Yeah, yes. So if this is the x value, we're going to plug 10 into the whole equation. Here's the equation, x squared minus 20x plus 105. You see, there's the equation. We're going to plug 10 into the x because here's the x, 10. So 10 squared is 100. 20 times 10 is 200. And when you add all that up, you get 5. So our y value is 5. Our x value is 10 and our y value is 5. That's our vertex. And don't forget, it's also going to ask you about the axis of symmetry. Remember, axis of symmetry always starts with x equals, and it's always whatever the x value is. That's the axis of symmetry. If I were going to graph this, I would have a vertex at 10, 5. You see, there's my vertex at 10, 5. And it's a parabola that looks like that. It's just a parabola that looks like that. The axis of symmetry is a line that goes right through it, that splits that graph in half, goes right through the vertex at x equals 10. So you have to be able to find the vertex, know that the axis of symmetry is x equals whatever the vertex x value is, and you have to understand that to graph this, you know, if all parabolas start off here, and if the vertex is at 10, 5, then the parabola just goes up from there. Now, it says now write it like this, in this form, in the vertex form. I'm not too worried about A right now, but look what happened. Here's the original vertex. Here's a new one. Do you see how we went up 5 spots? We went up 5 spots. So up 5 means you have to put a plus sign on the outside, a plus 5 on the outside. That's where the original went up 5. On the inside, we went to the right 10 spots. There's an X in there. To the right, remember, to the right is a negative. And we put the 10 in there. So this is what the graph looks like in vertex form without A. I'm not too worried about that right now. It's, can you spot the correct graph? This is the graph. This is the answer in vertex form. In reality, if we put 0, you see, if we start off by putting 0 into the X, that it'll tell us that's our Y-intercept. If you put 0 in there, you get negative 10 squared, it was 100. 100 plus 5 is 105. See, if you put a 0 in there, you get 105. So in reality, A equals 1. They have that A there. You have to put that, you have to put 0 in there to find the Y-intercept. The Y-intercept is 100. If you put 0 into this one, you should still get the same 105. And I do. 0 minus 10 is negative 10. Negative 10 squared is 100. 100 plus 5 is 105. If you don't get that, then you'd have to put a, like, let's say I got 35. If I did 35, then I'd have to put a 3 for A because 35 times 3 is 105. All right, so that's 5. Let's look at number 6. Same thing. So we're going to go through the same process. I think it might, I don't know. Let's look at the vertex again. We're going to do the same thing. What is the vertex of this? I think we might have did it a different way before. But the vertex is negative B divided by 2 times A. A is 2. B is a negative 4. Don't just say 4. B is a negative 4. So negative B divided by 2 times A. B is negative 4 and A is 2. So negative negative on top is a positive 4. 2 times 2 is 4. 4 divided by 4 is 1. So our vertex has a 1 in the X value. So to find the y value, you plug 1 into the x values and it'll tell you what y equals. 2 times 1 squared minus 4 times 1 plus 12. This is 2 minus 4 plus 12, which equals 10. So y equals, when x is 1, y equals 10. There's my vertex. If I wanted to graph this, there'd be a parabola at 110. And there's the graph. Now, there's a 2 in front of the x squared, which means it stretches up. This graph is a little skinnier than a normal one. But that's it. You have to understand this graph. That 1, 2 is the vertex. That, I mean, 110 is the vertex. Now, I'm going to put it in this form. Y equals ax squared plus k. And once again, this graph, if you look at it, we already said it went up 10 spots. Here's a normal parabola. This graph went up 10 spots. So we're putting a 10 on the outside. That went up 10 spots. And then it went to the right only 1 spot. You see, it went to the right 1 spot. To the right is a minus, and that's what we get. Now, if I put, watch what happens here, and we can actually see this. If I put a 0 in the original, by the way, we're doing number 6 right now. If I put a 0 in the original problem to find the y-intercept, put a 0 here, y equals 0 minus 4 times 0 is 0 plus 12. You see my y-intercept is 12. That's my y-intercept. So if I put a 0 in the equation I have, put a 0 in there. Give me a second. My pen stopped writing there. Put a 0 in there. 0 minus 1 is -1. -1 squared is 1, a times 1. You see, my answer has to be the same thing I got down here, 12. The only way to get 12 in this problem is if a is 2. 2 times 1 is 2. 2 plus 10 is 12. So that's where I can erase the a now. It's not 1, it's actually 2. So in the original, oh, I should have erased it there. We could have put the 2 right there. If we put 0 into x, we get 12. Same was down here. If you put 0 into the x, you get 12. So doing that y-intercept only tells you what a should equal. In the first one we did, it was 1. In this one, a equals 2. All right, we're going to do number 7 next. And 7 and 8. So there are 2 word problems on the test. Similar to these, but not exactly. So this is our function. Can somebody tell me what this graph looks like? Does anybody know? Does it look like this? Or does it look like this? You should be able to tell me what this graph looks like, A or B.
B.
Yes, it is B. It's a parabola. The highest power is x squared. It's a parabola. It's a parabola. But a negative in front of the parabola, don't forget, a negative on the outside of the parabola. So then don't look at that because makes it upside down, you know, it makes it flip on the horizontal axis. So the answer is B, not A. But, and this is important, do you see what rainfall produces the maximum? Do you look at it? That is a maximum. Do you see? This, the vertex is the maximum here. If we had a parabola that looked like this, the vertex is the smallest part. It's the minimum. So it says, what is the maximum? Which means the vertex looks like this one over here. So we want to find the maximum rain, what rainfall produces the maximum number of mosquitoes. So we just need to find the vertex. And we're going to do that on both of these problems. Now we've already done that. Remember vertex, you have an X component and a Y component. The X value equals negative B divided by 2 times A. This mosquito is, I like to put it in order. So you see it's not in order over here. The highest power first, negative X squared and a positive 16X. So if you look at this, A equals -1 and B equals 16. A is always the number in front of X squared. B is the number in front of X and the C is the number without the X. So it's negative B divided by 2 times A, and B is 16 and A is -1. When you put that in your calculator, negative 16 divided by -2, you get 8. So our vertex has an 8. By the way, it says what rainfall produces the max number of mosquitoes. Can somebody, we're using X and Y's. So either the X or the Y is a rainfall. Which one is the amount of rain, X or Y? Does anybody know which one is the amount of rain, the X value or the Y value?
Y.
Y value.
It's actually the X. Look, wouldn't you agree that the function is the Y value? And that's mosquitoes. Do you see the mosquitoes in millions? So the Y value is mosquitoes. The Y value is mosquitoes. The X value is the inches in rain. So you can look at the function and see what the Y value is. The Y value is mosquitoes. So the highest point is 8 inches of rain. Do you see? That highest point, or the X value, sorry, this is 8 inches of rain. This highest point is 8 inches of rain, it looks like. What rainfall produces the max number of mosquitoes? So that 8 inches of rain produces the highest point. The Y value is the number of mosquitoes. So all I have to do is take the original equation, 16x minus x squared, and put 8 in there, and it'll tell me how many mosquitoes was the maximum. So 16 times 8 minus 8 squared, and I get 64. But mosquitoes are in millions, so in reality, it's 8 inches of rain produce 6 million mosquitoes. 8 inches of rain will produce 6 million mosquitoes. So we're going to do the same thing for the number 8. if I can get it down. There we go. A watch shop has found the cost of operating his shop is given by this. So the Y value is the cost. Do you see the cost? X is the number of watches. Number of watches. And you see this is a 2x squared, so it's a parabola. So it has a lowest point, a minimum. What is the lowest cost? Do you see a lowest cost minimum? So the question matches the function. It's always going to. So the minimum cost is the vertex. We need to find the x and the y value of the vertex. To find the x value of the vertex, it's negative b divided by 2 times a. B is negative 18. That's b. Negative b. B is negative 184, not 18. And then a is 2. Divided by 2 times a, and a is 2. Negative is 184 divided by 4. 184 divided by 4. And I get 46. So X is the number of watches repaired. 46 watches got repaired. And now we have to find Y, the cost. There's the function, 2x squared minus 184x plus 4532. And we're plugging 46 into it because that's how many watches there are to find the lowest cost. 2 parentheses 46 raised to the second power minus subtract 184 parentheses 46 close parentheses plus 4532 on my calculator. I got 300. So the lowest cost was $300 to do 46 watches. All right. So now we just have one more section to cover. I don't see any of that. Just, I thought we had some questions that asked about end behavior, but no. But I do have a question here. I mentioned it briefly in class, but I'm not sure anybody picked on it on turning points. X squared has a maximum of 1 turning point. Do you see, whatever the power, you have to subtract 1. So the power is 2, so you subtract 1, you get a turning point of 1. In other words, in a parabola, it turns once. You see an x squared graph, it turns once. An x3 has 2 turning points. The highest power, minus 1, 2 turning points. It's not always guaranteed, but it has a maximum of 2 turning points. A negative x to the third looks like this. It turns once and then it turns again. You see it has two turning points. X6 has a possibility of 5 turning points. By the way, X6, we already talked about, even powers has this. It turns once, 2, 3, 4, 5. 1, 2, 3, 4, 5. You see 5 turning points. And it doesn't have to turn like that. It could turn like this. But it's a maximum of 5 turning points. So that's one of the type of questions on this part. But I don't think I covered it briefly, but I really didn't discuss it a lot. I didn't see any question. Oh, it did say what was the maximum turning points. I must have covered it then, or I didn't see that. What was the max turning points? Did anybody have their workbook? Did I cover that in class? I don't remember. Okay, so here, find the x and y intercepts. When you have a graph like this, or a parabola, find the x and y intercepts. Well, the x and y intercept, the x-intercepts are what makes the y equal to 0. The x-intercepts are right here. One x-intercept, x plus 1 equals 0. Take the 1 to the other side. So you see -1 is an x-intercept. And we also have this one. This is a -2. It's going to be the opposite side sign that's in there. X plus 2 equals 0. So take the 2 to the other side by subtracting 2. And x -2 is an x-intercept. We also have one more. 2x squared equals 0. Divide by 2. If you divide 0 by 2, you still get 0. And then square root both sides, x equals 0. So the 3 x-intercepts here are 0, -2, and -1. Those are x-intercepts. By the way, give me a second. This is going to be kind of important. Can you tell me another word for x-intercepts that we use? X-intercept is also called a 0. So x-intercepts are 0. So if it says find the zeros, that means find the x-intercept. So x-intercept is the same thing as saying find the zeros. So now that we have the x-intercepts, we can graph this. There's one x-intercept at -1 right here, one x-intercept at -2, and one x-intercept at 0. Oh, these are x-intercepts. Though we have to be able to find the y-intercepts also. Y-intercepts, don't forget y-intercepts, x equals 0. So in the original equation, change all the x's to zeros. 2 times x squared times 0 plus 2 times 0 plus 1. That's 0 times 2 times 1. 0 times anything is 0. So the y-intercept, is 0 also. So this is the x-intercept and y-intercept. This is x squared. That's an x and x to x. So total is x4. Remember, x4's even power x's, the end behavior, both are up. The 0 has a 2, so an even power, so it bounces. Remember that? This has a power of 1 and a 1, so it goes through. So from here, the 0, it bounces, it goes so far, then it goes through, then it goes so far, comes back, goes through, and goes up here. We don't know how far those went. If you can just draw this, you're fine. To find out how far, you can do a test point and plug it into the original problem. Those were what we did. But you have to graph the x-intercepts, graph the y-intercepts, know what the end behavior is, and then just pick the correct graph. You have to know whether it bounces or not. Actually, you're not even going to pick the correct graph. You're just going to list it looks like you're just listing does it cross the intersect or touches? Oh, by the way, I said bouncing. So at x0, at 0 down here, I say bouncing. It bounces off of it, but the book uses the word touches. So you see it comes to 0 and it touches it and then it goes off. I call it, I mean, most books say it bounces. Our book calls it, it touches it. It doesn't go through, it touches it and then goes back up. It goes up. So just so you know, it touches it. And I'm going to erase some of this. So we call this, I'm going to erase the whole thing. We call this a multiplicity of 2. These have powers of 1, so those are multiplicities of 1. Those are multiplicities of 1. So if you look at this, -2 has a multiplicity of 1. -1 here has a multiplicity of 1. And our x-intercept of 0 has a multiplicity of 2. So that's what they're looking for on one of the questions. And multiplicities are just another word for power. Find the x and y intercept. So we did that on this one also. So we wouldn't have to graph these, so I'm not going to worry about graphing these. It doesn't look like, but let's find the x and y intercepts here. X-intercepts, look, there's one x-intercept, x equals -2. Here's one, x-intercept equals +1. It's always the opposite sign. And there's an x-intercept of 0. So we have x-intercepts of x equals 0, x equals 2. Oh, wait, -2. It's opposite sign. And x equals 1. X equals 0 has a multiplicity of 1. X equals 2 has a multiplicity of 1. And x equals 1 has a multiplicity of 3. It has a power of 3. The only thing we need to do now is find the y-intercept. Y-intercept is when we change all the x's to 0. 0 times 2 times -1 to the third power. When you multiply 0 times anything, you get 0. So our y-intercept is 0. All right. Almost done. Hang in there. I know we're running out of time. We're almost done. It's 3.5. Yeah, 3.5 is one of them. I'm trying to get to the question. Here we go. Let me see if the next one asks. It's just telling us to sketch those graphs. So on the test, it's not going to say sketch the graphs. It's going to say find the vertical asymptotes. So you're going to see a problem like this, and it's going to say find the vertical asymptotes. Vertical asymptotes are what makes the bottom equal to 0. 2x plus 9 equals 0, and x plus 1 equals 0. We'll take the 1 to the other side, and x equals -1. That's a vertical asymptote. Here, you got to take the 9 and the 2 to the other side. You always take the add and subtract to the other side first, then divide by 2. That's the other vertical asymptote. So to find vertical asymptotes, you take the bottom of the fraction and make each part equal to 0. All righty. That was vertical asymptotes. Now, remember horizontal. There are 3 rules for horizontal asymptotes. If the top power was more than the bottom, there is no asymptote. No horizontal asymptote. If the top power is the same as the bottom power, the highest power and the top, then the horizontal asymptote is horizontal asymptotes always start with y equals, by the way, is 2/5, is 2/5, the number in front of the powers. And if the power on the bottom is larger, here the larger on top, here larger on the bottom, then the horizontal asymptote is always 0. Always 0. See, I have a power of x to the 1 on top, and on the bottom I have 2 x's. I have a power of x squared. The bottom here is larger power than the top. Larger power than the top. So the horizontal asymptote for this problem is y equals 0. If the bottom power is always higher than the top power, then it's y equals 0. And I want to look at one more. What is the horizontal asymptote here? The powers on the top and bottom are the same. The highest powers are the same. So if it's the same, it's the numbers in front, and the numbers in front are 1/1. So the horizontal asymptote, by the way, horizontal asymptotes always start with y equals. So the answer to this question, find the horizontal asymptote. See, number 6, it says sketch it, but on the test, it's just going to say find the horizontal asymptote, and the horizontal asymptote for that problem is y equals 1. All right, that's it. That's the test in a nutshell. There are 25 questions, I believe, multiple choice. Let me hit stop recording. There we go.